Starting. All attendees are in listen-only mode.
Hello everyone and good evening. My name is John Brown. I'm Technical Product Manager here at Mobilize.net. Thanks for attending our webinar today on how to move your captive desktop Windows applications up to the new reality of cloud deployment, web browser-based client, scalable across elastic server farms and so forth. We've got some pretty interesting stuff to show you here today. What we're going to try and cover is a little bit about where our background, very small amount about who we are. I'd like to spend just a few minutes discussing what are the technical challenges involved in moving a legacy application that still has value to the web. I'd like to talk about different approaches to deal with your portfolio of legacy code and how to sort of decide what to do with each application that you have. And also, of course, most importantly, we're going to demo some technology here that I know you're all going to be excited about seeing. And then we'll have some time at the end for Q&A. So if in the meantime, if you have a question that you want to ask while the webinar is going on, there's a UI in the GoToWebinar panel where you can actually type in a question. We have some engineers on the webinar from our team that will answer those either privately if it's very discrete to your issue or publicly if it seems a more general question. And some of the more interesting ones that not everybody can see will bring up at the end of the session, plus whatever additional questions you have. So let's get started. Mobilize.net has been around for a couple of decades now. We're a mid-sized software development company that focuses on developer tools. You've very possibly seen some of our tools as part of Visual Studio from Microsoft. Until Visual Studio 2008, there was an automatic wizard that would upgrade a Visual Basic 6 project to either VB.NET or C#. Replace the VB Forms package with WinForms and replace the VB runtime with .NET when you opened it up in Visual Studio. That was what Microsoft called the Visual Basic Upgrade Wizard. We built that for Microsoft. They are a part owner of our company and a very close partner of ours. Over the years, we've created tools that have been used by customers all over the world to migrate literally millions and millions of lines of Visual Basic code to now let's talk about some of the issues involved in moving an application to the web. First of all, when you start thinking about a Windows app, you have a lot of things that are available to you that maybe you've come to take for granted because we've been doing Windows development for so long, building apps for the desktop. So, for example, Windows has a authentication model for the user built into the Windows startup, as well as, of course, very tight integration with Active Directory for the enterprise. You have a private local file system. It's very easy to write a stream to the file or read a stream for the file. It's very easy to create those objects as well. You can peruse the file system directory by directory, file by file. You can do searches and things like that. The memory that's running for your Windows app is private to the process that you've created. The objects that you create in memory are going to persist in your own process space until you explicitly destroy them. So you can count on that level of object persistence and encapsulation. You have the registry in Windows where you can store specific information pertinent to a particular user or a particular session, such as the last files that were open, the state of the application the last time it was used, for example, the arrangement of windows on the screen, colors that the user selected, things like that. You have a very rich capability for building user interfaces and user experiences with .NET at the application level, and also sitting on top of Windows. With the ability of Windows to give the user accessibility flexibility in terms of size of font or text-to-speech, things like that. You have a very rich forms package. You have a very rich controls package as part of .NET. And we've all become, I think, really accustomed to the ability to just drag and drop controls off the toolbox and put them on a form and write code behind those forms to handle events. And of course, finally, the last thing I'll call out explicitly is that your desktop computer, your laptop computer has a hardware stack that's built in as well as peripheral devices through ports like USB. And you can access those devices in a very secure way, but a very easy way through the Windows API using the device drivers. And so you might be able to always assume, for example, that the user has a certain kind of a device attached, whether it's an audio device, a video device, a peripheral device, like maybe a barcode reader or card scanner, something like that. Now, when you think about a web app that's going to run inside a browser, what you basically have available to you is you have HTML, which is theoretically a document structure markup language. You have styling through CSS, either inline or externally in style sheets, to format the markup. You have some additional things like the ability now to play videos as part of HTML5, but you also have JavaScript, and you don't have a lot more than that. So what you really have to think about as you move that Windows app forward to the web is potentially redesigning the things that do not exist on a browser, such as hardware access or a local file storage, coding around or replacing things that you can potentially find a replacement for example, office automation or custom control, redesigning something or rebuilding something along those lines. You have to think about that application now potentially is going to be accessed by more than one user at a time. So when we think about a Windows app, the database may be being multi-accessed, but the individual applications are typically being accessed privately by one user for one instance, which won't happen in the web. And then finally, you really have to think about scalability, because you may have dozens or hundreds or thousands or tens of thousands of users accessing the application at a single time. Now, when you look at the portfolio across your organization of legacy applications, how do you decide what to do, what the outcomes or the strategy should be for those individual applications as they go forward? So where do you devote your resources? So one way to do this, and we'll go through this very quickly, is to plot out your applications on a two-axis matrix, where on one axis you basically score them according to the criticality to the business. How functionally unique are they, or how much competitive advantage does that code create? And on the second axis, you measure them on their technical maturity or their technical quality, their technical obsolescence. So you're looking at things like, is the business logic, the algorithms that encapsulate that, is it accurate and robust and free of bugs? Does it create, is the workflow around this application useful? Is it a stable application, or does it crash a lot? And then in terms of how current the application is, things like language, for example, is it in COBOL, is it in Visual Basic, is it in RPG, or is it in C# or some more modern language? You look at the platform, what operating system does it sit on, does it depend on? And look at the architecture. Is it loosely coupled? Is it tightly coupled? Is it single tier? Is it multi-tier? So as we do that, let's take a look at where some of these applications might wind up. So the ones that are critical and good, you probably want to just keep those alive, invest in them, maintain them, fix any bugs that come up, and add features. So that's your sort of your top right quadrant. The ones that are not particularly critical, but are still have good quality and are on modern platforms, that's really your do-nothing category. It doesn't make a lot of sense to invest in them if they don't offer a lot of business advantage, but by the same token, they're in good shape, so you don't really need to worry about fixing them up. The bottom left quadrant really is the worst situation, because it's low quality and it's low value. These are applications that a lot of times have been around for a long time. Maybe they were written by an individual department rather than by the IT group. These are candidates to be replaced with commercial off-the-shelf software. So you might think about using SAP or Salesforce.com or Microsoft Dynamics, maybe writing some custom code and workflows around it, but replacing those proprietary apps with commercial apps. Finally, up in the top left quadrant, let's further divide this area of high business value but low technical quality into three subcategories. The first is that the application does not functionally do what you need it to do. So the business logic isn't good, the features are not there. These are applications that are good candidates for complete white page rewrite. Start from scratch, redo it, go to management with a set of requirements and a project plan and get rid of that thing because it's not worth investing in. The second category is applications that, again, have high business value, but they're bug farms. They crash all the time, they're buggy, they're not reliable. These are applications that possibly are telling you that there's something wrong with your development or your QA process in terms of the development disciplines and standards that you've implemented and enforcing the process that you have to certify code before you put it into production, the way that you deploy it through operations. So this is a place to go and look at how to repair these so-called bug farms. Finally, there's the category of applications that have great IP. You have business logic that's really proprietary and valuable, and it's proven, it's been debugged, it works really well, but they're on obsolete languages or platforms, or the architecture is not very good. These are great candidates to modernize through automated migration. So you can use migration tools such as the ones that we will show you. You can move that entire code base up to a new language, a new platform. And we're not talking about a syntactic translation here. We're really talking about an intentional translation where you wind up with code that looks as if you had written it by hand, but it does what it did before, but it's now in a place where you can start adding and building on it as a new platform rather than having something really old that you're trying to keep alive. So what we've done is we've created technology that basically allows you to go from as far back as Visual Basic 6 through a sort of an intermediate step of .NET, C#. For some people that's a great terminal node, but in this modern world, you know, with multiple operating systems and multiple platforms being used more and more today outside of the Windows domain, maybe it makes more sense to think about taking it all the way to a truly cross-platform solution, which is, we think, a great one is HTML5. Okay, it's native, it's clean, it can do what you need it to do. So that's what we're going to show you today with WebMap, which is we're going to start with VB. We're going to take that VB application with automation to C# and .NET. We're going to then take additional automation and move it from C# .NET over to the web. Now, how does that work exactly? Well, what we'll do is we'll take the WinForms version and we will pull the all of the WinForms UI stuff out of the application, and we will rebuild it as HTML5 with JavaScript to handle events and create widgets and controls, and CSS for styling. So it will be a very straight-ahead web app on the client side. On the server side, we're going to take the .NET code and we'll leave the logic intact. We won't actually change it, so we're not going to introduce new bugs, but we're going to rebuild it as an ASP.NET MVC4 application. So we're going to get the advantages of the model view controller pattern on the server side. We're going to make it a single page application so that the user interface will resemble very much the existing Windows version of the application. For example, we'll create a frame that will instantiate forms in, and those forms, because we're starting with an MDI application, those forms will actually be MDI. So you can deploy this as a web app without having to retrain your customer base. Okay, but of course, because it's a web app, if you want, you can restyle this to make it responsive, to make it look more interesting, look more modern, and so forth. So actually what I want to do now is get right into the demo. So what we're going to do is we're going to start with something from a long time ago, and here is Visual Basic 6. Wait, you can't see it. Okay, so here's a Visual Basic 6 application, and it's running on Windows 8. It doesn't run great on Windows 8, but it does run. And it is very much like most Visual Basic applications. Let me just fire it up here. So this is a fictitious app that we wrote as a demo, which represents a typical app that you might have for a sales function inside of, in this particular case, it's a seafood wholesaler. We call them Salmon King Seafood. And the application is able to understand things like customers and orders and inventory and sales and so forth. It's built on top of an MDB database, which is local on my machine. Of course, that database could be upgraded to SQL or SQL Express and deployed in a corporate data center or in a cloud or something like that. So what we have here is a lot of data-bound controls. We have a VB style buttons at the top for sort of a quick menu. There's nothing really particularly exciting about this application. So let's take that and actually convert it now initially to C# and .NET. The way we're going to do that is we're going to use the Visual Basic Upgrade Companion. The newest version is 6.3, and what we can do with this now is actually load the solution, and I've already done that, and look at our Visual Basic solution, all of the controls and components that it accesses. So you see a lot of the standard ActiveX controls that are used here, like the common dialogues and things like that. We're using ADO for database access. So it's basically what BBUC is saying with these green check marks here, is that it has located all of these controls that are being accessed by the code. So now what we can do is go in and look at each of the programming objects or patterns that we have and decide how we want to change them as we move forward. So for example, we can decide what we want to do with error handling. In this case, we're going to convert error handling to C# try-catch patterns. So take out the on-error go-to pattern that we had in VB. We can decide how we want to handle database access and so forth. When we're finished, we confirm it. We're going to pick our output option as web map, and then we're simply going to click on the upgrade button to start the upgrade. And so what it'll do is it'll actually start processing the forms and going forth. Now, I'm not going to sit here and let this run. It takes a while to run. This is a fairly large application. So let's just jump ahead into the output of this application. And to show you what that looks like, we have created a new directory here of here it is, with some upgrade support and a new upgraded application. So there's now a bunch of designer files as well as C# files. Let's look at it in Visual Studio. And you can see that here's, for example, from the customers form, here's the event handler for the button click on one of the toolbar buttons. And you can see that the code has been commented. You can see that the variable names and the method names now from the subroutines are exactly the same as they were before. The code's very readable. If you were familiar with the VB app and you have an understanding of C# syntax and a little bit of an understanding about the .NET runtime, you'll be able to jump right into this program in its .NET version and do whatever you need to do with it. So let's actually fire this up. And what we can see is that, once again, we've created something that looks very similar to the original application, which was exactly what we intended. We've translated the VB menu bar up here into these iconic menus. We've created basically the same data-bound controls. We're still accessing the database. Now, I haven't changed any of this code. The only thing that I've done is move the database to where the code is looking for it. So it had a relative path to the application space. And so I just needed to make a copy of the database where it could find it. Well, this is great. We've got a Windows version of a VB app. You know, for some people, that's as far as they need to go. But today it's a lot more important, I would say, to think about the future, and the future isn't necessarily just about Windows anymore. So what do you do if you want to take this thing to the web? Well, fortunately, we now have a tool which you can try yourself, and it's called studio.mobilize.net. This is a portal where you can access our latest technology, WebMap 2, to transfer, to migrate that .NET code to the web. So what I'm going to do is I'm going to show you what that looks like. I've got an account here, and I'm just going to sign in. And now we're going to see a place where I have my existing solutions. I have over here a place where we can look at some demo solutions, and one of them is this same Salmon King Seafood SKS application that I'm showing you today. So you can take a look at that just by registering and going on here and looking at the solutions if you want to learn more about it. But what I want to do is create a new solution. So this is how we would go about starting this process to move our application to the web. The first thing we have to do is we have to collect some data about the .NET application to understand how well it's going to map line by line, object by object to the paradigm that we've created for modern web applications. So we're going to run an assessment tool that will generate some XML data, and then we'll analyze that XML data and show you what the output is. So we start by downloading this little assessment tool, and I'll run it. And so what it's going to ask me for is my account information, so it knows how to take this assessment data and who to attach it to when it sends it back up to our web app. So we're going to start this. So I need to point it to the application. In this case, it was Salmon King Seafood, the C#.NET version. So I point it to the Visual Studio solution file. And we'll go ahead and have it run an assessment. Now, again, what it's doing here is it's actually counting each property, each method, each event in the entire application. It's counting all the lines of code. It's counting, going to calculate how many lines of code are supporting form design of the designer packages, and how many lines of code are actually logic lines of code, if you will. And then it's going to give us some information about that so that we can see the size of our application, we can see what's contained in our application, how many classes and methods and so forth. We can also see an indicator of how, in effect, ready it is to migrate to the web. Now, I've actually already done this, so while this one's calculated, let's just jump ahead to one that we've already uploaded and run. So in this particular case, what we're going to see is that this Salmon King application is fairly large. If we look down here, we'll see it's about 12,000 lines of code. There's about 4,500 lines of actual logic code that we've written. And just jumping back into that, here we are. So, and we also see in this readiness chart that about 90% of that code is green. That is to say, it should migrate through automation right over to the web, and you really shouldn't have to do anything to that code once it's been migrated. So of our 12,000 lines of code, that's, you know, in excess of 9,000 lines of code that will go over right away. About 5% of the code in this application, and I know which 5% it is just not available on HTML5, and that's because in the original VB app, we had a button in the help form, the about box, if you will, to look up user information from the applications, the operating system and the computer it was running on. So it would access the Windows registry and pull back and display information about the operating system version, how much memory was available, how many disk drives were there, what version of things were there. That's not available on HTML. You don't even know what operating system you're running on when you're sitting in a browser. So that code is just never going to be available on HTML, so it's not going to migrate. Of course, it won't harm anything, but it will be there as basically as dead code that you might want to extract later. And then finally, there's this yellow range of about 5% of this code, and this is code that the assessment tool was unable to be absolutely certain about the exactly what it was or whether or not it would move over to HTML very well. So this is code that you should, if you see a lot of this, you want to ask about it, just give us a call. We'll take a look at the specifics of what those PMEs, those properties, methods, and events are, and let you know what it would take to move those over. It might be that they're ready to go today, or it might be that we're about to create another release you know, in the next week or so, and then they'll be ready to go, or it might be that we just need to do a little bit of customization for your project. So be sure and give us a call about the yellows that you see. There's a lot of information here. I don't want to go into too much detail on it, but you can see over here on this p-invoke, these are all the things, these registry opens and queries that are the red stuff that won't migrate. We do have a dependency analysis here that you can look at and play around with. Not much to show on this app. It's a fairly straightforward app. You can look at all of the references that are used by your project. We have a breakdown for each of the forms as to how much of the code is design code and how much of it is logic code. We also can tell you all of the controls that you've used, both at the system level and at the application level. We can tell you all the APIs that are used for each control. So this is a very granular level of detail, but it's helpful for us to understand if you have a problem, exactly what exactly is going on here. So when we get to this point, what we can do now is actually migrate the application over to HTML. So all I have to do really is click on this button, and I have a configuration screen with, right now there's two choices. Those choices are related to the way fonts are going to be declared in the HTML client and basically how we separate the code between the client and server. Let's start with fonts. When you create a Windows form, one of the default properties is fonts, and there's always a default font. The font declaration is part of the designer file, but you can go into the properties toolbox and you can go in and you can change those fonts by setting properties or by explicitly setting them in your code. Since Windows has a lot of default fonts that are included in the current version, and there are enormous numbers of font packages that could have been installed on the user's machine, it's possible for you to set all kinds of different font declarations that maybe don't exist in a browser on a different machine. So you have the choice here to basically explicitly declare fonts for each form with each object in the CSS files that are going to be created. Whether those fonts exist when the user runs the application in a browser or not, those declarations will be there. So if in the HTML you declare a font, or rather in CSS, if you declare a font and use it for an HTML ID that doesn't exist, a default font will be used. The alternative here is the default in this setting is to not declare fonts at the form level, but just declare them at the site-wide site.css file, and they're going to be just a typical set of default fonts. I think it's a sans serif set like Verdana and so forth, which is a little more common in a standard HTML web approach. So again, you have that choice here. Secondly, we're looking at code separation, whether we want to optimize for size, which is the default, or speed. And if I click here, it'll tell me a little bit more about these options. If we optimize for size, again, the default, then we'll try to make the client application as small as possible. So we'll get faster load time, and potentially we'll get a little faster run time. But that means that we'll make more server round trips. Okay, so we'll do almost any kind of calculation has to happen. We're going to keep that on the server side to keep the client small. If you optimize it for speed, then what we will try to do is put JavaScript on the client side to handle those sorts of validation and calculation algorithms that don't require a database lookup, don't require a reference to something that's only available on the service. So that's really your choice. That will reduce the number of server round trips, but it may make the client a little larger. So of course you can try it both ways and see, what the output of the code is and how it shapes up for you. Once we've set our migration configuration options, we click on the next button, and the step that has to then happen, and it looks like my browser locked up, so let me jump over to a different version here, is to pick one that I've already done here, because I'm not sure what happened to Firefox there. Okay, so the next step would be to migrate, and what we would do in that case is we would simply go to our source files, and in this case we would take this one. We would take all of the code that was generated. If we use VBUC, we take all of this code, including these helper classes that are in the upgrade support. We need the database because that was part of it, and we would simply send these to a compressed folder. Okay, so we'd simply zip these up, and then what we would do is drag that and drop it onto the portal. So basically, as a way of uploading files, we just drag and drop them, and then we migrate it. Now, once we migrate it, you're going to get an email. It might take 5 minutes, it might take 2 hours. It really depends on how big your app is and how many people are in the queue in front of you. But once it's migrated, you'll get an email, and you'll get this view here. So once we've migrated it, we can go over here and look at the application and compare now the new application with the old application at the file and folder level, and also at the code, individual lines of code. So let's look, for example, here and make this maximized, and we see that on the left we have our old files. This is our .NET C# version, and on the right we have our new files. And notice if I click on this request approval designer file, it highlights over here this request approval HTML file. If I click on this request approval CS file, it comes down here and clicks on this one as well. But we've also created a controller file for request approval. We've created a view model for the request approval. So we've created our model view controller pattern, and that means that we have more folders, we have more files. Now we can look at these individually and get a little more information. For example, if I minimize that and then look at this, here's our request approval C# file from our Windows app on the left here, and on the right here's our new code. So you can see right away that we're using a lot more helper classes. We are changing the code around, in some cases, quite a bit. And also, as you get down into, let me just get down where I can scroll this over a little bit. There we go. You can see now that where we were accessing individual controls before, we're now accessing a view model of those controls as part of our MVC pattern. So the code will be, particularly the backend code, will be very familiar to you, particularly if you're used to working in ASP.NET MVC. If not, we can certainly help you with some training and some resources there, but I think you'll find that once you understand how the code is structured, that you'll be very familiar with it if you knew the original application. So let's actually look at one last thing here before we fire it up and see what it looks like. The other thing we can look at in this view is we can see all of our forms now have been recreated as HTML, and we actually have an ability to do a quick preview inside of this UI of what that form would render like, so we can basically see if the controls are there. Now, if you call a control that we don't know about, custom control, for example, what we'll try to do is to understand the location and size of that control on the form and mark out an empty area for it. So it looks like there's a couple here where basically there was a grid control that we don't know how big it's going to be depending on the database lookup, so we're just blocking off some space. Now, what does this look like when you actually run the application? So let's open it up in Visual Studio. And I have already migrated it, so I've got it right here. There's some temporary files you can ignore, but there's a directory called Migrated Solution. And now we see it's gotten bigger because it's a much more rich application. But here's our new solution file. Let's open it up, see what it looks like. We're using NuGet to manage the packages for all the dependencies for a lot of the Visual, or a lot of the Microsoft and .NET stuff. So here's our application. Let's just collapse everything real quick. And this support project here is actually an artifact left over from all of that registry lookup stuff, and so it's got some p-invoke stuff in it, and we really don't care about this, so I'm just going to pretend it's not there. We have obviously we have our NuGet stuff. You can see what's getting called here if you go and look at the targets. We have a bunch of helper classes here, which are all written in source code. They are basically ways that we're using to make it much simpler to have the code migrate in a very familiar way and to handle some of the changes between .NET and a web application. Most of the time you won't need to do anything with these helper classes. You might step into them when you're debugging. You'll certainly see a lot of references to them in the way that we handle things. But the bulk of the project is here in the SKS project. So now we see that we have all of our forms at the root here. These are really our logic files. Let's open up the one we were looking at before, which was, here it is. So again, we see that that same code has a lot of familiarity. Here's the same comments that we had before. Here's a lot of the same variable names. Of course, now they've been decorated, if you will, because we're using a call to a view model that we've created for these. For every form now, we're going to have an HTML version. So let's find that same one, and now here's what the HTML looks like. So every control on the form will have its own ID in HTML, and it'll be data bound. As you can see right here, here's something that's going back to that toolbar, that Visual Basic toolbar that we then recreated in C#. And every form will also have, of course, styling via cascading style sheet. So for each object here, we've created the properties that were in, largely they were in Windows, and so we've brought them across and we've mapped them to CSS definitions. For every form now we have a model, if you will, and so if we look at the model file, we're going to see that we have mapped those user elements, those controls, to a view model of that, and you'll notice that we're doing a resolve here. And rather than instantiating objects with new, we're doing a container resolve because we've created, using inversion of control, a context for the application in order to manage the state. So one of the problems that we talked about earlier with a web application is that you have to be able to sort out which session is this coming from. You don't have private memory. You have basically a process running on a server that's handling multiple users coming at it. So when it gets a stream of data that it has to deal with from a client, it has to know whose client was this so that it can go back and understand what am I supposed to do with it. So we're attaching a session ID, which is a unique value, kind of like a GUID, to each session. And so as we create JSON objects to stream the data, which we've serialized from the client after the user clicks, let's say, submit on a form, we take the data that the user has entered into that form, we serialize it as a JSON object with this unique ID, and we send it to the web app running on the server. The web app then takes that and creates a response that has that unique ID as a context. So we're using some techniques here like inversion of control and the Unity framework in order to do this, so that you can sort all this stuff out. And what that also means is that the server side for this is automatically ready to be deployed across a server farm very elastically. So as the application runs, if you get more load on it, you can configure Azure or AWS to just build more servers and spread this load across. So it will basically take all of this state information that we're processing at any given time, and it will copy it across those servers and keep those in synchronization. The other thing that we're trying to do here, of course, is to make the application performant. So when you are in this situation where you've got, let's say, 10,000 users running this application at any given moment, you need to be able to make sure that you're not going to hog your servers every time somebody presses submit, because you're sending so much data back and forth. So what we've done is we have a thing called lazy loading, where we are serializing the data, but we're trying to make sure that we only are transmitting, if you will, data back and forth that's actually been changed. So we're not just taking all of the state information and wrapping it up and sending it to the server, and taking all that same state information, wrapping it up after we've changed it and sending it back to the client. We're trying to manage the delta of that state, so we're only synchronizing the things that have actually changed at any given moment. And that keeps the application performant, it keeps the server side performant, and it keeps the round trips as fast as possible. Finally, you're going to see that for every form, we also have a controller file. And this is basically where we're going to access all of the logic and make sure that we understand how to access the database, how to handle any back-end operations. So again, this is standard MVC stuff. It's a very well-known pattern, and this is exactly what we're using. So what we're going to do now is build this and run it in debug mode on a browser, in this case Chrome. So I'm going to launch my build here in Visual Studio, and we're going to run this, of course, in locally, so it's just going to run on localhost. Now, we have chosen for the initial release of this a JavaScript framework package, which is Telerik's Kendo UI Professional, and we chose it for two reasons. One is that it has a rich set of well-tested controls that are give us a broad coverage on the existing set of controls that are available through the Windows toolbox in Visual Studio when you're building a .NET app. The second reason is that the way that it presents these controls on the browser are very similar to the way that they look in Windows. So for example, if we look at the customer form here, wow, it looks a lot like the .NET version. Well, that's by design, because most of our customers have asked us to not redo the user interface when they migrate an application to the web, so that they don't have to retrain their users, so that this application will be very familiar to their users. They'll know how to use it right away, but they can deploy it immediately as a web app with all of the reductions in cost and complexity for deployment, because they don't have to worry about configuration, they don't have to worry about DLLs, they don't have to worry about any of those things. You can see that the app works exactly as we want it to. We've created the controls and positioned them and sized them with font information and properties, styling properties, so that right out of the gate it looks really good. Certainly we could clean up a few things here. That we might want to have a little space here between this control here and its label. We might want to position this on the form in a slightly different way. But for the most part, it's great to go right out of the box. And the nice thing about it is that we didn't have to write any code to get here. This is just a translation of existing code. So now what about if you wanted something in the way of a responsive design or something like that? For right now, what you would want to do is take a web developer, a web designer, and go into those let me stop debugging for a second. Go into all of your HTML files and your CSS files, and you could create new HTML based on the existing HTML that styles it in a different way. And you could even include Bootstrap if you want. Or you can use a different pattern. We are very shortly going to release a version of this product for people that want to use Angular and Bootstrap, so that you have a slightly different look and feel for the application. It looks more like a modern web application and less like a Windows application. And of course, it'll be responsive. So the user can run it on anything from a small smartphone to a tablet to a laptop or a PC. And the user interface will not break because of different sizing issues. Now, you really have to decide, are you trying to create a web app that you want, for example, employees to use as an internal tool that you don't have to retrain them on, or are you trying to take perhaps a piece of commercial software that's running right now as a Windows app, and you want to have it look great and work well on a variety of different devices and look very modern? That's kind of your choices around which of these frameworks and HTML styling tools you want to use. Now, the other thing, of course, as I said, was that the app is ready to run directly on the web. Let me show you. Here's a place where we actually are running this in on Azure, and we'll bring my want to bring my address bar up because it's right now it's showing MSN. Why is it showing that? So actually, this is, and you can go to this website yourself. It's sksdemo.azurewebsites.net, and that actually is this application. So we have, all we have done to do this is we've used the Visual Basic, we used the publishing wizard in Visual Studio to publish it to an account that we had on Azure. We created a Azure profile, which is a little file that you simply attach, and it has your account information, your password, and so forth. And then the application's database, we simply upgraded to SQL Express, and we have that hosted up in Azure. So if you want to try this out and take a look at it, it's up here and it's available. I'm going to jump back to our presentation and just do a quick recap of what we were talking about here. So what did we see in our demo? Well, we started with your classic VB app. It had all, of course, your common controls like data access and text box and grids and stuff like that. It was MDI with multiple forms. And we were able to move that first to .NET using the Visual Basic Upgrade Companion, where we changed the VB Forms package over to WinForms. We changed the syntax and the language from VB to C#, and we were able to migrate all the Microsoft controls, and we can also migrate a lot of third-party controls like Sheridan and so forth. But then we used Web App to migrate that to the web using, of course, our new hosted portal, and where you can stage your own migration or look at our sample code. Excuse me. And compare the existing code to the new code, so you can see very quickly how the pattern changes. Again, we are, in this particular paradigm, we're using Kendo. We're able to maintain the original look and feel of a classic Windows program because that's what some people want in some circumstances. For the next version, we'll have a very different look and feel. But for right now, we've implemented MDI basically on a single-page application inside the browser frame. We're running this with no browser plugins. So this application, again, you can try the hosted version on whatever tool you want or whatever browser you want. It should run on Safari, Firefox, Chrome, IE, current version, and -1 versions. Basically, any browser that supports HTML5 should run these applications. So it's ready to go right up to the cloud. It's ready to be deployed across the server farm. Now let's talk about a couple of real customers that had problems and how they solved them using this technology. The first one is a customer called National Systems. This is an ISV who sells call center software, And really the biggest customer that they have is Pizza Hut. Pizza Hut has a great ability where if you call and order a pizza, the telephone call is routed using voice over IP to call center agents that very frequently are home workers, home office workers who work part-time handling these calls. They have this application that they can look at and they can take an order for pizza, and then the order shows up on the in the kitchen of the pizza shop, the Pizza Hut shop closest to where the customer is, so that the pizza can be made and cooked and then delivered to the customer. But the call might have been handled 1,000 miles away based on load balancing. So they had created this application as a VB app, and deploying it and maintaining it and sending out upgrades to literally thousands of their call center agents around the country was just very cumbersome and expensive. So they wanted to have it converted to a web app so they could just send their users a link and they could access the app directly. They had to be sure that they would have 100% uptime on this application. The number of pizzas that get ordered and built by Pizza Hut on high pizza nights like Super Bowl Sunday when everybody in America is watching the Super Bowl, or on Halloween when I guess all that candy isn't enough for people, the numbers are just staggering. We had no idea, but they told us that they can make 50,000 pizzas just at Pizza Hut in one day. So they had to be able to handle very high volumes. They wanted to be able to deploy this as a SaaS application and change their business model over from sort of the licensing model to the subscription model and so forth. So we were able, after they had tried to rewrite this from scratch to move it from VB to a new application as a web app, we were able to migrate this for them with very quickly and very affordably, and let them deploy this without having to wait years to get it rewritten from scratch and debugged and sorted out and tested. And they were able to use this very quickly. So they were very happy with this, and this is certainly one model for ISVs to build a new version of their app. A second ISV is a customer called Hutchins Systems. They have a credit reporting system for automobile dealers to check credit worthiness of people who want to buy a car before they make a loan. A lot of dealers in the States broker these loans from banks directly, so they needed to be able to tell the customer right there in the store if they can arrange different financing options for them. Again, they had a very similar problem to National. All these customers had these VB apps. They were trying to access MDB databases. Deployment and updates were extremely difficult. There was a lot of configuration issues. They're dealing with car salespeople. Not that there's anything wrong with that, but they're not necessarily highly trained as technical people in computer software or managing computer configurations, so there were a lot of issues. By employing WebMap to convert from VB to the web application, Hutchins was able to, again, change their business model from a license and update and maintenance mode to a subscription model. They're able to roll out updates to the application anytime they want, basically by simply updating the application on the server, and now the user gets the new application. They wanted to be able to, like National Systems, to not have to retrain their customers. So they were interested in something that could preserve the look and feel as much as they wanted from the original application. In this case, whereas National wanted an application that looked exactly like the VB one, Hutchins wanted an application that looked modern, but they wanted the forms to all have the same controls. They wanted the tab order to be the same. They wanted for people who were used to the existing VB app to be able to get on this web app and use it right away without any confusion. And so, again, they were very happy with reducing their deployment and maintenance costs, being able to be more flexible, more agile in terms of delivering updates to the customers, as well as being able to change their business model over to SaaS. Well, this has been a lot of information, so before we get into Q&A, I just want to urge you to try it yourself. You can get an account on our website, mobilize.net/register. Once you get that account, you'll be directed to our hosted environment here, or a safe sandbox, if you will, where you can look at our demo code, you can upload your own code, you can run assessments and analysis on your code base and find out what it's going to take to migrate that code. We're wrapping up a canonical example that will help you understand a little bit better the structure and the flow of the applications in our pattern that we've created, again, ASP.NET MVC single-page application using inversion of control, so things like JSON and AJAX. So it seems like a lot. It can be a little overwhelming to a Windows developer to look at this new world of the web. We're here to help and to show you how we do it and to help you understand that code. I will tell you that recently I was talking to a customer who was at the end point of this process, and we had done a lot of assistance with them to move their application over using this technology. And I asked their chief architect, who had never worked on a web app before, I said, well, how did you feel when you first saw the code? And he said, well, it was a little terrifying because there's a lot of it, and he said it wasn't what I was used to with the Windows application. But he said, but as I understood it more, and as you guys walked me through it, he said, I was really impressed with the way that you approach some of these problems and the way that the code is structured. So I urge you in the same vein to take a look at the source code, take a look at the examples that we'll make available to you, and ask us questions. We have a lot of great engineers who really understand this stuff, and they're happy to talk to you. Okay, so now let's take some questions. System requirements, to use our sandbox, all you really need is a compiled version of your .NET application. It does need to be written in C#. Right now, that's the only language parser that we're supporting. And it needs to use WinForms. We're not able yet to migrate WPF applications to the forms package that we're using with our JavaScript framework. Question from the panelists or the attendees here about our security model. All of our sessions are in HTTPS, so they're running under SSL. When you upload your code, again, the code is encrypted, via the SSL communication stack. So it's stored in Azure. Obviously, Azure, Microsoft, they have an enormous amount of physical security around their customer data that's being used by tens of thousands of very large customers to store lots and lots of data.
Go ahead. Support.
So question on, do we support Angular, Knockout, Bootstrap, all these things. Again, reiterating, right now we're supporting Kendo UI. If you use this version of WebMap, you will need to get a license from Telerik for the Kendo UI Pro. I think it costs about $900 or $1,000. It's a little steep, but you only need one license. Angular, we have a version that we've used for customer work on Angular that supports the Angular JavaScript framework. It also uses Bootstrap for responsive design. We've delivered applications for customers using this. We're putting the finishing touches on adding it to the product so that you can use it without our assistance. But if you want that immediately, we can do the migration for you, and then you can take the generated code and you can do the finishing up work on it. Or, we also have a services side, and if you have an application you want to migrate and you want to leave your development team focused on other projects, we can do an entire migration from start to finish for you and hand it back to you at the end just so that you do the user acceptance testing. Well, I see we're out of time, and we really appreciate everyone attending. Again, if you have questions, feel free to follow up. My email, johnbro@mobilize.net. We can get you in touch with our migration architects for deep drill downs. Or we're happy always to, under NDA, look at your code and give you some feedback on issues and expectations around migrating either to .NET or, better yet, to the web. So thanks very much, and I hope all of you have a very good evening.